Hello, everyone. Welcome to ITS 350. Okay, so let's get started. So I'm going to share. Oh, this is in the wrong place. So you should be seeing the Brightspace environment. Okay. So as you can see here in the Brightspace environment, today we have made it to PyCrypto lab. So the module PyCrypto, that's what we're going to be working through today. So this is more of a practical coding type of a day, and instead of just me lecturing. As you know, you will have to do, this is sort of one of your two practical exams on cryptography, and you will have to demo this one, right? So this is sort of like a lab. You'll be working in pairs, right? So you have to find one teammate, partner, and work with them to achieve all these objectives. Okay, so I would also recommend that you take a look at, actually we can take a look at the calendar. Where is that? Yeah, here. So you should now be seeing the calendar. If you notice, I have updated the calendar for the remainder of the semester. So you can see here, we are currently on week 20, this week, October 27th. So today is this day. And you can see we're going to be working through PyCrypto for the next 2 weeks. Okay, so I'll start today laying out the ideas, the problems. Then you'll work on them with your partner on Thursday. Then again on November 3rd, I'll go over some additional things with the PyCrypto, and then you will do your demos, which is basically your practical of the PyCrypto on November 5th. So that day, I need to sit with everyone for a few minutes and, obviously sit, metaphorically speaking, online somehow. You'll share your screens and you'll need to answer the questions and demo the problems, basically, okay? Then on November 10th, we will have our second exam, which, remember, the exam is comprehensive, so it'll include everything that we have covered from the beginning of the semester until basically November 5th. And then after that, on November 12th, you will have your crypto practical exam, which, if you remember, this is what I've said when I hide a message, by encrypting it a lot, right? So I'm going to do a lot of types of encryptions, and then I'm going to require you, I'll give you keys that are also encrypted. And so your job for that day will be to decrypt. So this will be a one-day exam. I will post it at, 4 o'clock, let's say, and then you'll get a few hours, probably until later in the evening, to finish it up, okay? And then after that, I just have a few additional topics that we need to cover related to the principles. And then I remind you, your term projects are due on December 8th and December 10th. So you'll do presentations of your topic. Remember, your term project is 10% of your grade. You have to research a topic and do a demo. So you have to either write some code or implement something. If you haven't done so already, make sure you form groups of 3. Send me the email, 1 email per group of the team members. And you need to send me in that email a list of 3 topics that you want to, that you're interested in, and then I'll reply to you which one I recommend. So make sure you don't lose those points, as that is 10% of your grade. And that will be presentations during this week. And then, of course, the final exam during finals week. All right, and that is as you can see, the schedule is laid out now, and we're getting pretty close, you know, to the end of the semester. We have what, 2, 4, 6 weeks plus the day of Thanksgiving, you know, that one day during Thanksgiving week. But if you think about it, it's not really 6 because presentations start here. So really, as far as new material, we have 5 weeks. 1, 2, 3, 4, 5, 5.5. All right, so we're almost to the end of the semester, you know, and, you know, that's basically where we are. So today we're going to do, as I said, the PyCrypto lab. Are there any questions about the calendar at this time?
I don't think so.
All right, great. All right, so then now we can get to this. As I said, this is the last. This we'll be using Python, but as I said, my goal, the code is not terrible. It's very easy. It's not algorithms. It's just a whole bunch of functions to read the files, write the files. But in particular, what I'm looking for is your understanding of, you know, what is confidentiality, integrity, authentication, when to use what key, and all of that. So you will practice the problems, and then, as I said, during the PyCrypto demos, you have to demo things to me. So I'll let you demo the problems. If you do it right, you know, you'll have probably very few questions. If I start seeing that you're confused about things, I'm going to really start asking more questions. Okay, so that's basically the plan for that. All right, so that is the calendar. So now we can go back to the Brightspace environment. You should be seeing Brightspace now. And if we take a, so I'm going to close this module and this module. All right, so now if we scroll down here, this is the PyCrypto. So if you notice, there's 2 files in here. There is a .tar file, targc file. That means it's a compressed Linux file. So you're going to have to download this tar file into your CVM. Okay, you can download it into the CVM, and then I'll let you know how to proceed with the installation. Okay, but you'll need to download this. So pretty much everything that you have to do for the next 2 weeks is laid out in this document. In this document, I just have instructions on how to install the software, and then also what problems you need to work on. And remember, on the practical exam, or the demo, I could actually ask you to do other things. So I could modify the problems a little bit just to see, you know, how you do on them. Okay. So let's start reading through it. Okay. So, so the PyCrypto, which stands for the Python Cryptography Toolkit. So this was developed, and this should be available at this website if you click on it. I haven't clicked on it in a while, but that's why I have a copy of it in Brightspace. I'm sure the Seed Labs also has it somewhere, but you know, usually since we're still using 1604 VM, it always works on 1604 at this point, so there should not be any installation issues, as that's the version of VM I've been using for a couple of years now. So now if you used 1804 or 2004, you know, we might have some issues there, but as long as you're using 1604 or the CVM 1604, you should be fine. All right, so you don't have to get it from this website. The files are attached. So what you have to do is, on your VM, you're gonna, from Brightspace, you're going to download you're going to download that GC file and extract it. Okay, then once you do that, you're going to CD into the directory, which means just navigate into the directory. And on the terminal, you will need to do install sudo apt-get install python dev. All right. Sometimes you can also do sudo apt install python dev, but basically install this. Then after that, you should read the README file in the folder so that you know about the copyright issues. Okay, and then after that, you're going to run on the terminal sudo python setup.py build, then sudo python setup.py install, and then sudo python setup.py test. All right, so that's something that you need to run. Once you run the last command, it starts to print a lot of dots. It just prints a dot, prints like several rows of dots. And then after you start seeing the dots, it's either going to stop or it may not stop and you just have to kill it. Or even if it crashes, I do believe that once you see all those dots, the program is installed correctly. So you will need to let me know if after you run all of this, you don't get all the dots, okay? That's the first thing. So I need to know if you can install the program, okay? Then after that, just that's basically one of the things I want you to do we're just testing that the library works, okay? Then after that, these are some of the problems that you will have to do for the practical exam. As you can see, it's not that bad. So basically, we're going to look at hash functions because I may ask you to calculate integrity. I may ask you to do a digital signature, those kinds of things. Also, encryption with DES, right? So here, we've talked about block ciphers. So you're going to, for symmetric key encryption, you can use DES. I may also at some point cover AES, in another example, etc. Then also RSA signatures. So you'll have to, remember, I'll give you the code, of course, for this, but, you'll use these tools to achieve your objectives with RSA, as you know, as asymmetric encryption. So then the problems are that you're going to develop a script that encrypts some data, and you're going to develop a scenario or experiment where you send it from one machine to another, such as via email. And you're going to test that the encryption works. Okay, so you develop a script that encrypts some data and develop a scenario or experiment where you send it from one machine to another. All right, now that's just, I'm telling you the general sense of what the question will be. But remember, I may ask, can you achieve confidentiality, authentication, integrity, all those kinds of things. So you have to be ready for that. All right, and as I said, all I will do is give you some starter code, but I'm not necessarily going to give you solutions per se. Just, I will give you working code though. All right, and then the final problem, 5 that you should practice to be ready for the practical exam is the RSA public and private key encryption. So, we're going to create some public and private keys. We're going to send an encrypted message. You're going to send an encrypted message to a classmate via email. You can use your classmate's public key to encrypt the text message or the key, and then email it as an attachment. The message should include your name and other relevant information. Only your classmate will be able to decrypt the message because only they have their private key. So this is what you need to show in your demo that you understand really well. Then you're going to encrypt the message with your private key. Your classmate can decrypt the message with your public key and verify that it came from you. Here, remember, it might be that you just do that for the hash. It might be that you just do that for the key. So various scenarios, right? And you just have to show, we really don't do that for the actual message, but you need to show your understanding of all those elements. And then once you have completed the assignment, document what you did, copy your code, your public and private keys, as well as the message you sent, and received indicate your name and the name of your classmate you communicated with. So remember, even though you will be demoing this, I still need a report. So each student will submit a report from their perspective and include who they work with, and then I will use that when you do the demos, basically. You will need to provide also the message you sent in plain text and encrypt it, the message you received in plain text and encrypt it, okay? So as you can see, it's pretty straightforward. It's everything that we've done before, except that, you know, you will need to demonstrate all of these things now, okay? All right, so so those are basically the problems. So as you can see, it's pretty straightforward. So now what we have to do is we're just going to move to the virtual machine. So I am going to navigate away to the virtual machine. Okay. All right, so here we are in the virtual machine, and I'm going to open up a terminal. Okay, so there's the terminal, and I'm going to navigate to the desktop. And I'm going to navigate to 350. Right, and we had all those scripts that we had written before, right? And some of those could help you out. So what I'm going to do now, as I said, I'm just going to go over the code, and I'm going to give you the scripts, but you have to use them to basically solve these problems. Okay, I'll explain how they work and everything, but what I'm looking for is that you will use them. Now remember, I did say that there's some additional information about APIs and like PyCrypto in the book. So if you check in sections 21.6 of the book and also in section 23.7 of the book, you might find some additional information as well. All right, so since we are here, I'm going to create actually a new folder. I'm going to call it scripts PyCrypto. All right. Remember, you have to install the library, so I will leave that for you to do. Okay. And I'm going to navigate into the scripts here. And then if you have any problems, let me know. Are there any questions so far?
Would you like for us to follow along with you as you're doing this?
It's up to you, if you'd like.
Okay.
I mean, I'm not going to post these scripts, so the only way that you can get them is through this, right? But I'm recording the session, so you should have them. All right. So I've talked about the problems. I've talked about how to install the software. And now I think we are ready to give you, so I'll give you a lot of the scripts, okay? My goal, as I said, is in fact to give you all the code so that you can just use it, but I may forget something here and there, or I may think it appropriate for you guys to figure out a specific part. So in any case, you have plenty of time, and just make sure that you're ready 2 weeks for the demos, okay? Because those are really important. All right, so let's start doing some example code here. So I'm in scripts PyCrypto at this point. So I'm going to create the first script. I'm just going to call it integrity, right? So there's some. What is the question that So what's your question? I had a question for someone. What's the question? The README file is in the folder. When you download that file that I showed at the beginning, the .tar file, there's a README file in there. So what I said is just read through it. You don't really need it for anything except just read the copyright, read the fact that they're saying some things about, this was implemented by someone, right? So as always, whenever, what it means is, as always, when you're implementing someone's code and you decide to use that for security of your organization or your own personal, just be mindful that, you don't know who wrote that code, right? So you don't know if it has vulnerabilities or things like that. And so that's what that implies. Now, I'm not saying it's secure or insecure, right? Either way, I'm just saying you always want to be mindful of that. In particular, if you're trusting a cryptographic library. All right, so, yep. So now let's go ahead and, as I said, I think I said we're going to create a integrity script. Integrity. All right, and I'm just going to show you basically here how to use the scripts. You can make them executable. You can just run them with the Python interpreter. It's up to you. So if you want to make them executable, you usually just have to type a path here, user bin Python, to indicate that that these are Python scripts, and that's the location of the program. Then after that, you can basically import the crypto library. Okay, so you can import crypto like that. Usually though, what we're going to do, and this is, of course, this will only work after you've installed the library. So you have to do that first, following the instructions I gave you, or the book might have some more details. All right, so now since we're doing integrity here, I'm going to do from crypto.hash import MD5. And you can see that's basically it. It's that simple, okay? So we're not writing here algorithms. We're just using a library that has so we're not actually directly XORing anything, right, anymore. When we were doing that in the previous lectures, we were just trying to learn we were just trying to learn how the algorithms work. Here, we're actually my focus is just on using them and making sure that you've got the principles clear. Now, I'm just going to write all this code and explain it, but I will leave it to you to run it, okay? It will be up to you to solve all of these. And in particular, as I said, to prepare yourselves. Now, keep in mind, definitely work with a partner. That's one recommendation that I'm going to give you. Don't work alone, because you have to work with a partner on the practical. Find someone. And sometimes I've noticed that students, when they do things alone, everything works. Once they have to work with a partner and figure out how to change what key and everything, they do get confused. And so basically here, just practice. All right, so once I've created the MD5 or have the MD5 module, what I can do is I can create an MD5 object, MD5 object. All right, and we can just say new. All right, and that's pretty much it. Now we have the object and we can use it to encrypt things. So for instance, in a hash function, we would want to, check if two strings are the same. So for instance, I have string 1, say string value, right? And that's going to be buy the stock at 2,500 a share. Right? Let's say that's the message that you were sending, but somebody intercepts and they want to change it. And so we're going to call that spoof string value, right? And then they say, you know, no, I want you to buy the stock at, they want you to pay more, probably 4,500 a share. Okay, and so these are two strings. They're different. Okay, they're different, and so when you're dealing with integrity, obviously you want to be able to check for that. So the way that you do that is you can type, now you have the M object, which is a hashing object. So you can just say m.update, and you're going to take the string value, right? And then you're going to, that's it. That's pretty much it. Now you can just print it. You can say print m.digest, the value, right? You can also print it in hexadecimal. You can say hash value. Like if you want to get ready to send this, because you're going to need to send this to your classmate, right? So you're going to say m.hex digest, okay? And then you can print out the message, okay? Are there any questions so far?
I don't think so.
All right, good. So that's it. Now, once you have that value, hash value, you just have to send it. You know, you probably want to write it to a text file, or you want to write it to a pickle file, which is a binary version of a file, and then you take that file, send it to your friend via email, and that's pretty much it. Now we're going to do the same with the spoof message. So let's create another object. We're going to say n equal md5 dot new, and we kind of repeat the same, n update, right? And then we take the spoof value. So obviously they're different, so they should have different hash values. So you're going to do string value over here, okay? And now you also get the, for the n, you get the spoof value. You're going to say n hash value, right? And you assign to it the n hex digest. So that you both have them in hex, okay? So hex digest. And then after that, that's it. So now you can print both of them just so you can see them. So you have hash value first, right? And then also n hash value. N hash value. So you have both of them here, and that should work out really well. The last thing you want to do is you want to automate this process of checking to see. You don't want to like visually look at them, right? You want to kind of do it automatically, and you will need to with the signatures anyway. So you're going to say hash value equal n hash value, right? So obviously 1, 2, 3, 4, the indentation. If they're the same, you print true. Else they're not the same. 1, 2, 3, 4. So you can print out false. And that's it, right? So this is the example of the very first script. Remember, this will work after you install the library PyCrypto, this crypto library. But that's basically it. Now, in the book, in the section 2.21.6, etc., there are more examples. Okay, so I would strongly recommend that you read all of these, because I'm only doing a few of the examples that I have from my own notes, and then I'll let you read the additional material supplement from the book, and then you can practice all of it. As I said, make sure you do those problems, but remember that I may change the problems a little bit for the demo, and for the practical, it'll be completely different problems. All right. So that's it as far as this script. So this is the script for integrity and hash functions. Are there any questions?
Yeah, can I see the bottom of the script real quick?
Yep. Which part?
Just that part. Oh.
Any other questions?
I don't think so.
Oh, all right, excellent. Okay, so let's keep going then. I'm going to do a second example now, and this one will be basically symmetric key encryption, block ciphers, right? So I know, we did the block ciphers last week where you implemented CBC, right? CBC mode of operation. So you have that code, and that works. This one we're going to do with PyCrypto, of course. So let's go ahead and start. So there's a question in the chat. Okay, so scroll down further, I believe. So let's see. All right. Okay, so now let's go ahead and all right, so that's our first script, integrity, right? That you kind of get the idea there. The next one will be, let's just call it, DES, Data Encryption Standard, right? So I'm going to create another one. And really, my goal here is just to show you, give you an intuition of how these work. What's the logic of the code? I will give you also some examples of how to read and write files, both with Pickle and with just regular, just so that you have that as well. But, I do want you to piece together these scripts yourselves. So it's really like Legos, right? I'm giving you a whole bunch of pieces of Legos. I want you to build them yourself, and definitely understand the principles. All right, so let's do this one, Des. So again, I'm just going to do this in case I want to make these executable. Given that on the test, you have to be very fast, right? Because you won't really have that much time. And so I strongly suggest that you have these scripts ready to go. All right, so this will be data encryption standard. So I can probably write something here. I'm just going to say encryption. So you should know by now this really well. Given a key. So we got a key here that we need to use. And you've already seen how to generate those keys as well. So you have, for instance, from last week's, how to generate those keys automatically. So here I'm just going to make up a key. It's not going to be a random key, which obviously means that the encryption is not that great. But, it's just an example. All right, so I'm going to do here from crypto again, but this time from crypto.cipher, and that cipher should be capitalized. Be careful with that, make sure things are uppercase. So from crypto cipher, import des. This also could be import AES. Okay, be aware of that. But in this example, I'm just going to do import des. Now I'm going to create my object. So I'm just going to call it object1. Should probably give it better names than object1. Okay, so object1 is going to be des.new. Similar approach. Here, I could have created a random key using last week's code. Instead, because I want to show you something about padding, I'm just going to do it this way. So I'm just going to say A, B, C, D, E, F, G, H, right? So you can see there's 8 characters there. Also notice that I'm going to do des.mode ECB. If you look in your book, these things can be changed to things like CBC, all right? At this point, you should understand what it means when that, mode ECB is implemented. And when you do your demos, I'll be watching for a lot of these things, right? And I'll tell you, is this secure? Is this not secure? And you have to kind of let me know. All right, so we've done that. You can also specify here if you need the IV, right? You would specify that in there if you were using CBC or some other model. So just be aware of that as well. Now let's just take some message, so plain, and I'm just gonna take some message here. I'm just gonna say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Work my way back. Some letters, that kind of thing. Okay. Now keep in mind this algorithm, and I'll write it here. Blocks. Oops, had a comment. Blocks need to be of a certain size, and you will have to figure that out. Usually, though, everything is in multiples of 8. So usually multiples of 8. But, I'm letting you find this information in the book, so go ahead and, read through those sections that I recommended. They should provide additional details on what needs to be done, okay? You can try other text. So that text, I randomly type characters. I don't know the size of it if it's a multiple of 8, so you'll have to modify it. One way you can do it very easily is just to do print length of plain, right? So that way you'll know, oh, okay, it's, looks like a multiple of 8, or it doesn't. Okay. So once I do this, then, I'm going to create a cipher, and the cipher will be, I'm going to take my object1, and I'm going to say that I want to encrypt. So I'm going to do encrypt. right? Object one, encrypt. And what do I encrypt? Now you encrypt the plain text. The plus sign is for concatenation. So you're going to concatenate basically the plain with padding, which can be spaces, characters, whatever you want. You have to figure out, take the difference between the length and then the multiple of 8 and then figure out what the padding should be. If you don't get the padding right, this will, this might give you an error. So figure this out. All right. Once you do that, you have your cipher, so you can just print it out. So you can just do print cipher. All right. Keep in mind, you need to coordinate this really well with your teammate, right? So here, I'm going to ask you guys to send the encrypted message. So you need to take this cipher, save it to a file, email it to your friend, and you need to exchange the key securely. So this is obviously very insecure. And so you need to figure that out and do that correctly. If you just paste that key in your email, you're going to lose points, and you should understand why, right? That's the whole point of all of this, is to understand when you're doing things correct and when you're doing them incorrectly. Your friend would then have, the decrypt. So, they somehow need to create an object, get the key as well, and then they would do object one, or their respective object one. Here is just object one, and the function is decrypt. Decrypt. And what do we decrypt here? We're going to decrypt Cipher. You see that? So that's basically how that works out. And that's, that's really all it is. That's it, guys. That's, it's as simple as that. That's how you do the data encryption standard and the for block ciphers or symmetric key encryption. Are there any questions about this one?
So the only thing we have to do for this one is figure out the padding and how to secure the key.
That's right. So obviously,
Okay.
if you were doing this securely, right, you have to secure the key in the exchange, and then send the messages, and then agree with your friend about the padding and everything. You can do that. You can't just give him the key over the phone. Plus, I would recommend that you use a randomly generated key, not how I did it. Okay, and you know how to generate those from last week. All right, so let's see there. So that's what I'm going to ask you guys to do, right? So I've given you the code. You need to run it and understand. So at this point, I did all the coding last week, but this I expect you to solve yourselves. So when we run this, what type of result would we get? A message encrypted or a message in plain text? Okay, so again, if you look at this code, you have a library, you create an object. If I have a plain text message here, right? If this is the plain text message and I encrypt it, then Cipher should be what? The encrypted version of it, correct? And then if I go over here and I say decrypt and I get Cipher, this should give me the plain. So this gives me plain text back. This is the Cipher version. This is extremely simple. All you have to do is run it. Okay, I mean, everything is there. All the code is there. I'm not putting any tricks or anything. All the logic is there, and you just have to print out the results. Okay. Yeah, so in a lot of this, you know, code is there. It's very, I mean, even the padding, this should be pretty straightforward, guys. I mean, we've done this a couple of times in much more difficult approaches. Okay, and I will give you the code on how to save files and all of that as well. All right, let's see. Okay, so I'm getting a question that says, do not email the key. What are ways to get it to our partner without meeting at Starbucks? You said you will lose points. So I think at this point in the semester, that's a question that you should be able to answer easily. So I ask you guys, how do you send the key to your partner securely? Remember, that's literally what I will be evaluating you on, having that knowledge. Okay, how? Don't just say encrypted. That's the name of the class. How do you, oh my God, if you could see me, I have like my hand on my forehead right now. How do you, the best way is not face-to-face. That wouldn't work. How are you gonna do that with Facebook, or if your friend is across the country? What is, so, okay, so somebody answered, okay, here we go. Encrypted, but they said encrypted with your private key. What does that provide? If you send the key and you only encrypt it with your private key, what is, okay, that now somebody said, and encrypted with their public key. Yeah, so encrypting it, remember, again, this, if you're still struggling with this, you know, really, you need to study more, because these are things that need to be extremely clear in your head. If we send the key that is encrypted with a private key of someone, what's the problem with that?
Anybody can decrypt it
Anybody
because
can have it, right? Because
public key.
everyone's public keys are available. Exactly. So that's you know, so
The only-
that's, you lose points immediately if you say something like that on
Isn't
the
the
demo.
only reason to encrypt it with the private key is just to ensure that it actually came from you, because that means only you could have encrypted it. So it satisfies like a different pillar, right?
Exactly. That's authentication. But you don't want to just do that, because you will authenticate, but people will have the key, and so that doesn't achieve anything. Instead, if Bob is going to send the key to Alice, how do they send that key to Alice?
You would want to encrypt it with Alice's public key. That way, only
Exactly.
Alice can decrypt it with her private key.
Exactly right. So please, you know, make sure that's the, so I want to stress, don't get distracted by the code. I'll be very forgiving with the code, but little errors like that of, hey, I'm just going to email it or tell them over the phone. I mean, that, you know, that's automatically wrong. All right. Any other questions?
No, I don't think so.
All right. Okay. So, okay, good. So now let's keep going. And if you have questions, stop me. So I gave you, as I said, for AES, check the book, because I will also, you know, I may throw in an AES in there at some point, right? So just make sure you're familiar with those programs. Oh, okay. So now signatures. So I'm going to close this script. All right, so I'm going to do control. Okay. All right, now you have two scripts here. Let's do a third one, which will be, let's just call this one signatures. Okay. .py. All right. So here, the same thing. We're just going to run the code. User bin Python. This is for signatures. RSA signatures. All right. So now here we probably need a few more libraries to consider. So I'm going to do from crypto.hash. Right. Remember the definition of signatures. If you've forgotten, make sure this is clear. MD5. I could ask SHA, right? So just make sure you check the book again for those details. Then I'm gonna do from crypto.public key. Now notice here I'm gonna start using the public key infrastructure. Notice that this is an upper K, okay? So public key import RSA, okay? Now here, I'm also going to throw in an example of how we could generate random numbers, maybe even generate keys randomly this way, so it's up to you. As long as you can, make an argument that you think something is correct, I'm fine with it. But I just want to make sure you guys master these things now. All right, so from crypto import random. Okay, and then RNG, that's going to be a random number that we can use sometimes. So I'm going to say random.new .read. Okay, and that just gives me some kind of a random number that I can use. Okay. Then I can say RSA key. Okay, I create a key. I'm going to call the RSA module, and I'm going to say RSA.generate. Now here, just like we did in one of the labs, we can specify the size that we want of the key, right? So here, 1024. You can try other values. We can also provide a random number to kind of provide a little bit more randomness. All right, so now, with that object, we're going to try to perform some of the RSA tasks. Okay, so we can say here plain text, and then just some message, right? Whatever you want. Usually, though, you're going to have to get these from a file, because I may give you a file. So just some random letters there. In fact, I will hide the secret in a file, so you'll have to be able to read it from there. And I may encrypt the file itself, so be aware of that. Okay, so now we're going to generate the hash value, right? So we got our plain text message. Because this is a signature, I'm just using MD5 for simplicity. And I'm going to say MD5.new, right? Another way of doing the hash is just to plug in the plain text in here. So I can just do plain text dot and then digest, remember? That's the hash value. Okay? And then now I'm going to show you how It can be easily signed with this library. We can just create the signature. So there's some notes in the book about this library. As I said, sections 21 and 23.7 and 21.6. Otherwise, I'm providing the code here, and that's why I'm going over all the details for you, right? I don't know what else I can tell you. I mean, it's, you know, it's the library. And some of it is in the book, but I would just, you need to implement this by yourself, right? Don't just take the scripts and just try to run them. You really, little by little, need to run all of this. Now, it will work. It's simple, but you have to do it. Let's see, another question I had was, is it okay if we send? Oh, okay. So I think the question that somebody is asking me is it okay to send the public key, your public key to your partner via email, right? That's what you're asking, Yash?
Yeah.
Okay. Well, you just lost 3 points right there. So that's also something you should be able to, you shouldn't need to ask me, right? That's something you can answer. What do you think?
Well, since your own public key, I mean, everybody can access it, right?
Right?
Encrypt messages.
Yeah.
So in this situation, like if I generate one private key and one public key,
Yeah.
I'm assuming that the other person knows my public key, right?
Well, you still have to. I mean, it's going to be a real private public key, right? So the only way for them to use it is for you to send it to them.
Exactly. So so since everybody can access it, should it matter whether it's encrypted or decrypted? I mean, if it's encrypted or not?
So you're going to encrypt the key with their. So let's run by your logic, right? So you're going to encrypt the public key. What are you going to use to encrypt it?
So I'm talking about like my public key.
No, I know, but if you're saying I'm going to encrypt it, okay? So let's follow your logic. How are you going to encrypt it?
With my partner's public key, right?
How is your partner
exactly? I
send you
need
his
to know
public key?
Yeah. So that's what I'm trying to like.
So he's going to encrypt it with your public key. So then you have to send him that public key.
Right.
You see that?
Yeah.
So then what do you conclude about that?
That I need to find a way to send my public key to my partner first.
But can anyone answer that question, guys? Anyone know the answer?
Yeah, you can send it in plain text.
You can send it, right? You can definitely send it in plain text, exactly. Because it's
Public knowledge.
I'm sorry?
Oh, I was just saying it's public knowledge, so yeah, it doesn't matter.
Yeah, exactly.
Okay,
So,
all right. Yeah, that's
All right.
was my question. Yeah, I
No,
was gonna
it-
send it in plain text, but I wasn't like sure whether you wanted to. But that makes sense. Thank you.
it's not what I want. It's not at all what I want. It's basically based on your understanding of all of this, knowing what's right and what's wrong. Or rather, what's secure and insecure. You see that?
Okay.
So that's all you have to say. If you can make an argument about it, you're good. Yeah, and so again, that little question, those are the little details that I'm looking for really on the practical exam. Okay? Not so much the code. Don't get distracted by the code. I can always help you fix the code, but you need to master these ideas, okay?
Thank you.
No problem. And like I said, today I'm giving you the code. On Thursday, when you guys, I'm just going to have an open lab on Thursday, and I'm going to let you run all of this. If you run into problems, you know, we'll get the code going. That's why we have, I'm giving you, you know, the practical, that demo is going to be a week from Thursday, not this Thursday. All right, so where were we? But good question, Yash, thank you. All right, so now let's go back to the, oh yeah, okay. So we were doing this, I need to sign, right? So to sign, I'm gonna take the RSA object that I created over there. Currently, that object has a public and a private key associated with it. So whenever we say RSA, RSA key, oops, RSA key dot sign, okay? When we say sign, immediately the object knows what's the appropriate key to use, okay? So just be aware of that. Now, what do we sign? We usually actually just sign the hash. So remember that, okay? And you're gonna have to share that random number just to make sure everything works out. And you can send that along with the signature, okay? And that's just so that every time that you're doing this, you're sending a different value instead of somebody getting the messages somehow, and because you're always having the same randomness, eventually they can crack the code. So it's just to add a little bit more difference in the messages that you're sending. And then that's it, you know, that's pretty much it. So then after that, what are some things that you should do? I will need for something like the signature, this is going to be a type of a binary message. So we're gonna have to save, it'll be more convenient. It'll be a type of data structure actually, not a binary, type of data structure. It'll be more convenient just to save it as a data structure or an object versus saving it as a text value. So what I'm gonna show you at some point later is how to save files as either text files or like objects, binary, that kind of thing, so that it just makes everything a lot easier for you. All right. Yeah, so you can, oh yeah, so what I was doing is you can print the signature here. Okay, you can print the signature. And then now you probably want to verify if this checks out, right? So if you want to view your signature to make sure it's correct, you can say RSA underscore K here, key, dot, if you sign, then you verify. It's very easy, right? So here's super easy because it does all the hard work for you. What do you verify? You verify the hash number, which you would calculate on your own, and then the signature, which you will receive from your friend via email. Okay? And that's, you know, remember we already discussed digital signatures. Now, for instance, I'll leave to you to figure this out, which basically means just run it. But here you have RSA key dot verify. And then if I just did this, I take hash, and if you think of hash as an array, I'm going to say, I want to look at everything in the array from the beginning all the way to everything in the end except the last element. So that's just a quick way of checking, of getting, you know, of slicing the data from beginning all the way to not the end, but the n minus 1. All right, and so obviously this signature, this hash is not the same as that one. And so when you do this signature, it will not check out. Okay, so this one will give you true. Should give you true. This one should give you false. Oops, I want to do that. Make sense? And that's it. That's the digital signature. Again, practice these so that you can, whenever I ask you the questions, you know how to demo things. Any questions? So when you send the file, remember, when you send something for a digital signature, you will have to send a file and this signature as well. Questions, guys?
I don't think so.
All right, great. All right, so we're making good time here. So that's, you know, we've done some examples of block ciphers, some examples of hashes, digital signatures, and now we are left with probably the biggest part, which is to do the RSA, right? So public, you know, generate public and private keys, share those, generate, create the encrypt, decrypt, and everything else that we can do. So let's take a look at this. Just want to make sure I'm giving you everything. Okay. All right, so the next script that we're going to do, we're just going to call that one, yeah, let's call it PKI, I guess. So I'm going to do Control X, Y. I got my scripts here. And now I'm going to create one called PKI.py. All right. All right, so same thing, you know, this is just going to be one big script with several functions. Same thing as before. User bin Python. And then, you know, kind of the same idea from crypto dot public key. Notice the uppercase K there. Import RSA from crypto import random. Okay, and then if we need any more libraries, we can always come back to it later. All right, so what do we need here? We are basically going to, you know, I'm giving you these functions to kind of make your life easier of how you can do this, the asymmetric encryption, and also generate your public and private key. So one of my goals is that should be pretty straightforward. So you're going to need at least several functions. You're going to need, you know, let's say first and only one time. So this is something that I don't want you to make a mistake here. So pay attention to this. Okay, so create keys, right? Let's say that you're going to establish communication with your friend, and you need to start doing everything with RSA, and you run this code. And this code has the functions create keys. It also has the function encrypt. It will also have the function decrypt. And it will also have RSA sign and RSA verify. It'll have RSA. Oh, let's just do it. Yeah, I guess it's fine. I mean, you can, it's the name doesn't matter. Sign and verify, which is similar to what I did previously, but here I'm just creating one single file that makes it a little bit easier. So I'll be using some of what I used before, but now with a little bit more support structure, if you will. So sometimes you will need to encrypt, sometimes you will need to decrypt, sometimes you will need to sign, sometimes you will need to verify. However, in this script, I will not tell you which key to use for anything. I won't tell you what's the plain text. I won't tell you what's the cipher. I won't tell you what's the public key. I won't tell you what's the private key. I will just for everything say the key. And you have to figure out what the appropriate key is for everything, okay? And sometimes there will be hints, but that's one of the main things that you need to make sure that you understand before the demo, okay? So, you run this script, and let's say you need to encrypt, right? And then you need to decrypt. The first, and you need to establish a secure communication with your friend. The first question I'm going to ask you is, how many times do you need to run the create function, the create keys function? How many times do you run it? How many times does your friend run it? Guys?
Somebody said something in chat. So
Oh, did they? Okay.
Yeah, I was gonna let them.
I'm
have-
sorry, I missed that chat. Sometime. Twice for you. Twice for you and twice for your friend. Why twice? Can you elaborate why twice? What do you guys think?
I was thinking once for each.
Once for each, right? Once for each. You just run it once for each, get the keys, right? Generate them into a little text file, and then do this. Comment it out. Because I've seen sometimes that students forget that, and then they spend hours not getting things to work, and it's only because every time they run everything, what are they doing?
Creating new keys.
Yeah, regenerating the keys. And so obviously the key that they send to their friend is not the same one that they have in their computer because they're constantly refreshing them, if you will. And so pay attention to those little details. Okay. All right, so, but these are the main functions that we will need: create keys, encrypt, decrypt, sign, and verify. Okay, so let's start with create keys. That will be the first one. So we need to define this function, and then I'm gonna give you the code also so that you can save them to a text file. All right, and that will make your life a lot easier because You can just save the files, look at them, rename them, whatever you want. Actually, renaming them is a good idea so that you don't overwrite them. And then you can share them with your friend. So I did the indentation. So now I'm just going to give you some of the code. So we're going to need a random number here. So I'm going to do random generator. And random dot new dot read. And then I'm gonna create something called key. You can call it key one, however you want. Key RSA dot generate 1024 random generator. Okay, so now you have your keys basically in the key object. And now all that we're going to do here is we're going to export them from like the data structure format to like more of a string readable format, and then save them to text files. And then from there, you can easily move them around. And, like Yash said, only send your public key, but do not, send your private key. Okay, so now I have the key, and so the trick is you're going to generate the public key, right? Now this is the actual public key, so all you have to do is say key dot export uppercase K key. Okay, so you can do export key, and that's your public key. And then the private key. Remember also when you open the text files, it usually says public and private key. Also, another way to know is when you compare both of them, you will see that the private key is a much larger key than the public key. All right, so then we say private key, and this one is going to be key dot, oh, did I say export key? I meant here. All right, so this is not right. This should, for the public key, it should be public key. Public key, that makes more sense. And then for this one, it will be export key. It's usually that the key that you have is the private key, and then you generate the public key from the private key. So now I'm gonna have key export. This one is uppercase key, and that's it. So that's how you get both the public and the private key out of there. And now to get the public key out of the data structure, because the public key object is currently a data structure, and to make it into a string, so I'm going to type here string pub key. All right, so you're just going to take the public key, and you're going to say dot export key. And that's it. So I could probably, just to be more clear here, I can also say string, and that'll just, tells you that these are actually strings or text. Makes it a little bit easier to handle. Right, so now we have both of our keys, and now all we want to do is write them. So this is going to generate the keys to the current working directory. So what we're going to do here is create an object. So I'm going to call it write pub for public key. And I'm just going to say open. And that just opens the file. I think we did this last week, if I remember correctly. And now I'm going to say public key, I guess. Public key dot txt. That's your public key file. And then comma write. Right, so that means you're going to write to the file. Oh, I want to say pub here. Okay. Then after that, we are going to literally write to the file. So I'm going to say write pub.write. And then what do we write? We will write string pub key. String pub key. And then don't forget to close. Write pub dot close. Okay. Then we're going to repeat the exact same process as you might imagine, but for what?
Private key.
Private key, right? Remember, this is the text file that you must keep a secret. Okay, don't send this file. You send it, if I see that in your email when you do the demo, you know, I'll say, hey, that's not secure. Okay, so then you do open. Here you create the file. You can call it like private key .txt. Okay, and then I'm gonna do write as well. That's the exact same thing. So write underscore private, oops, private dot write string private underscore key, and then finally you just close. Right. Private dot close. And that's it. It's as simple as that. Let me save this before I lose it. Okay. And you have at this point done the function for public and private key. You can see very straightforward. So, you know, let's say you're Bob and Alice. So each of you does this once. Then you comment out the file. Maybe rename the files a little bit so that they do not get overwritten. And then you're going to do all of your asymmetric encryption work now with this approach. Okay. Are there any questions so far?
I don't think so.
All right, great. Sounds great. All right, so now, what do we need to do? So we may not finish this code today, but we will continue on Thursday with it. I want to remind you for Thursday, make sure that you have gone through the installation of the library, the tar GC file. That should be pretty straightforward. As I said, you get to the dots. If you have problems, copy me and Mitch. But just make sure that you have that going for Thursday, please. If there's any issues, let me know. But it should work. Okay, the next step now. So now we've got create keys. Yes, I'm gonna scroll down to where? That's the whole function.
You were scrolled up earlier, so I
Oh,
think
was
he's
I?
good now.
Okay, there. All right, so the next thing, as you might imagine, that we're going to focus on is encrypt and decrypt. And then I'll leave RSA sign and RSA verify probably for Thursday, given that I don't think we'll have enough time to get to those. We will be using, yeah, okay, so that will also be, should be pretty easy. Okay, so we're gonna need to do the encrypt and decrypt. And that means that we're gonna have to import the appropriate key, okay? And you should understand when you need to use one key versus the other one. So as I said, for this, I'm just gonna do a generic approach, and then I'll let you guys figure out what the appropriate key should be. But the encrypt is pretty simple. You read the key, the appropriate key, you read the message, because the message also should be, it'll need to be a file that you send to your friend. And then you're going to take both of those and you're going to load the key from string to an object and then perform the encryption. And then you're going to need to write the output cipher back to a text file, okay? So that's really, everything that we have to do. It doesn't take that many. It's actually most of the code is just dealing with the files. So I'm going to go ahead and create a new function called encrypt. Okay, colon 1, 2, 3, 4. And then here, the first thing we want to do is we want to read key. Okay, so again, you're going to open the appropriate key file. And this time you only need to read. You don't need to write. 1, 2, 3, 4. Then we're going to say, temp string or something. And we're going to read that read key dot read. And we just read the file. And then don't forget to close. Read key. Close. All right, that takes care of the key. Then we have to repeat the exact same, but this time with the message. Since we're encrypting, we read the plain text, right? So you're going to read in the plain text. So read plain, open, input .txt. That's your message that you want to send to your friend. Comma, read. You also just have to read that one. I'm going to call this message. All right, so I have message here, and I'm just going to read the file. So I'm going to say read plain dot read. I read the text message as a string. And now I'm going to create the key, the object. So, or actually, I'll say this key object. So to be more obvious. So it's no longer going to be a string. It now needs to be an object. So we're going to use RSA dot import key, uppercase K. All right, and by doing this, we're going to take temp string, which has the key in a string, and we're going to load it up into the RSA object. So make string into object. Make key string into key. Okay. 1, 2, 3, 4. And now that we have the key object, we can just proceed to encrypt. So now comes finally, for all this work, we take the key object dot, and we perform encrypt. And that's it. You know, we do the encrypt here. What do we encrypt? We're going to encrypt message. This implementation sometimes takes a value 32 here, and you just have to hard code that. It just kind of specifies the size that they're going to use in there for one of the parameters. So just leave it set at 32. Okay, so now that we've encrypted the message, we are done. But you still want to send this to your friend. And if I just left it like this, you'd have the problem of how do you send that to your friend, right? So a convenient way will be to just store this in another text file that you can easily email. And so we can do that just by typing write cipher. We're going to open a file. You can give it any name that you want. Just going to call it cipher.txt. And then now this one you need to write, obviously. And once you have this, you can just write it to the text file. So you're going to say write cipher dot write. Now the way that this works is that the encoded data, which is the cipher here, usually, encoded data, the way that this library works is that it generates what are called tuples. Tuples are just lists like this, fixed lists of things. And so this is index 0, this is index 1. Okay, index 0, index 1. And basically the cipher is usually here. Okay, the cipher is here, and usually here there's nothing. There's nothing there. So the problem is you can't just write the whole object cipher. And I should say this is encoded data. Encoded data is that one. Right, but you can't write to a file the entire encoded data because it's going to give you an error. Okay. Instead, because it's a tuple of two things, let's say of two things. So we just want this one without passing this one. But that's pretty easy because we can just index it and just say, oh, by the way, just send 0. Okay, and that solves the problem. This will extract then a string, and then now we'll write it to the text file, and then all you have to do is do write.close, and that's it. At this point, when you run this script, you will have literally, you will have run the appropriate key, the appropriate input message, and it'll generate a cipher and then save it to a text file. And then now, when you are doing your demo, and I ask you, okay, send the, whatever you had to encrypt here with RSA, because you should know that, encrypt it and send it to your friend. You're gonna, whatever the output is, cipher, here, cipher 1, whatever, that's what you would attach on the email. I will look at it to make sure it's encrypted, but if you're using this, it should be encrypted. And that's it. That should do it for you. Does that make sense, guys?
Yeah.
All right, excellent. So this is a good stopping point. I still need to define the decrypt function, the RSA sign, the RSA verify. So no homework for Thursday, except that I'm gonna ask you to install, first of all, install the program that I gave you, the tar.gc file, follow the instructions on the Word document, and then start running these scripts, okay? Start with the simplest one, the shortest one. Make sure you understand all the outputs, do prints if you don't understand something. And then on Thursday, when we meet again, hopefully you'll have all these programs running, and then we can pick up where we left off. You guys can remind me of what I still need to finish, and we will go from there. All right, and that is it for today. Let me save this file actually before I forget. Don't want to lose it. All right, so. All right, guys, so work on these, please, enjoy, and as I said, practice, 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 because this should be like the culmination of all this hard work that you've done with all these cryptographic algorithms. You need to show that you master them in the next 3 weeks, okay? All right, so we'll stop here for today. I'll upload this video in a couple of hours, and otherwise, I will see you on Thursday. So I had a question, somebody asking if for the project they can implement basically DES, because they're asking if installing the Feistel network. I think that's good enough for a project, actually. I didn't implement DES. I only implemented CBC. And so implementing DES or implementing AES fully, as discussed in class, would be a good project, yes. Fully, but writing the code as opposed to just like configuring a program that does it, right? So that's totally different. All right. Okay. All right. So okay, another question. All right. So as I said, make sure that you have somebody to work with. Okay. So find a partner. All right. So I think you can use probably Brightspace to get on, exchange messages, etc. To find somebody to work with. If not, send me an email. I'll try to find you someone, but it's, you know, I don't like to force groups together, so you kind of have to see if you have somebody to work. Okay? Any other questions? All right, great. All right, have a good day, guys, and I will see you on Thursday.
All right. Have a good day.